Everyone, my name is Amanda Meng. I'm a research scientist and I work on the IODA project. Just for those of you who may not be familiar, at IODA, we provide a public dashboard with connectivity measurements. Our data should be interpreted as connectivity of internet infrastructure. Another source that you could verify our data with would be Cloudflare Radar. Shout out to David Belson um, on the Zoom. Or if you wanted to kind of understand, is there a problem with the internet or is something being blocked, you would compare IOTA data with UNI data. And similar to Censored Planet, we are based at a university. We're at Georgia Tech, and this project, IOTA, is run out of the Internet Intelligence Lab, which is led by Alberto Dainotti. Zachary Bischoff is also on the Zoom right now. He's my colleague who is a computer scientist and internet measurement expert. He'll be available to answer questions, and a lot of what we talk about today is work that he has led. So we're going to go through some recent releases and upcoming releases, focusing more on upcoming releases. I'm excited to share all of this with you. So, in terms of recent releases, we're very excited to share our more localized and greater granularity in our connectivity signals. So, as I mentioned, IOTA provides data on connectivity of the internet. We've always provided that data at the country, region, and ASN or ISP level. And with this work that we did, we were able to further localize network signals to a country or perhaps more powerfully to a region. So this is really important for networks that operate in several countries or networks that operate across different regions. So here we have a nice example of looking at connectivities in Sumy, which is an oblast or region in Ukraine. And you can see if you just look at the region level, there's definitely something going on. We see a simultaneous drop in two of IOTA signals. But if we look at the new localized view for Ukrtelnet, particularly in Sumy, we can see a much clearer picture that this outage was really driven by an outage in Ukrtelnet, particularly in Sumy. And I wanted to go through another example that we saw recently. And just to show you how you might navigate to this, if you go to Ukraine and then select Sumy, you can launch this ASN ISP raw signals, and this gives you a stacked horizon view of the network signals localized to Sumy. You could also toggle back to the old view, which is the global view of networks that operate in Sumy, but may also operate in other regions. And so when we looked at this view, we could clearly see that there was a drop in connectivity, particularly on Ukrtelnet in Sumy. And we can see that by the lighter blue, almost white color that we see. I think a lot of people don't always know about this pop-up or module that can be launched, but you access it down here in the table where you see the ASN ISP signals. So another example I wanted to go through is Panama. We heard from our Keep It On coalition partners that there was a reported shutdown in a particular region in Panama. And when we looked at signals at the country level, we couldn't really see anything. We did have our probes restart here at Georgia Tech, so you can see, or I'm imagining it was a restart, but you can see that there's some abnormal behavior in our blue active probing signal. But this was not indicative of connectivity in Panama. And we knew this because if you went to any country in the world, in the dashboard, you would see this same behavior. So we knew it was an internal issue. So then if we navigated down to this region of Bocas del Toro, we could see that there was some abnormal drop in both BGP and active probing. And again, launching this raw signals view, we could see this particular ASN where our active probing signal just completely dropped off. So this more localized view gives greater detail as to which networks in which sort of geographic areas are kind of driving an outage. So we published a report on this. You can access it via our reports page. I'll drop it in the chat later. And you can read more about what we did and why we did this and see that example that I just walked through. Okay, this has not been released yet, but we're very excited to share with you all that we have in our dev environment, and we'll look at it live, new data. This is our active probing latency and loss, and our goal with this is to detect generalized throttling or just to show other internet performance indicators. And we're using our active probing signal and essentially storing more data around latency. And for latency, we're measuring this with the round trip time. So how long does it take for response from our probes? And then loss being the probe or packet didn't come back to us. So did the recipient reply at all? And we were looking for an example to show you all. We noticed that several folks have been reporting on connectivity in Gaza and looking more recently this month at some fiber cuts that happened. And we could see that there was definitely an effect in our active probing. The probing loss rate jumps up, so an increase in loss rate. So let me see if I can remember which what tab okay, so here, this is our dev environment. You're seeing a little behind the scenes here. You can see that our packet loss signal goes up as the Gaza network stop responding to our probe. So we're excited about this signal, and we again will release a report with more examples of how you would use this. Moving on, this is something that we have already released, so hopefully you're very aware of it. We have a new user resource hub where we have a curated set of resources that we're providing, various tutorials, research articles. The research includes reports that we've done with our partners at Kintech or Cloudflare and Uni, as well as academic research papers that we've published that get into more of our methodology and technique. Right now, we do have a filter for internet freedom versus internet measurement. So it's really just a matter of how technical some of the material is. And then, of course, our glossary and our repository and data access. We will be adding more to this as we develop more content. Very excited to have an short animated video that helps explain our signals and how we measure active probing, BGP, and telescope. So look out for that soon. Another upcoming release is implementation of our dashboard redesign. We've got a lot of great feedback from users. Like, for example, some of our visualizations that may have been hidden, we're going to try to expose them and bring them out and not hide them behind buttons. And just want to shout out our Georgia Tech students as well as IODA Design. IODA Design also designed our little banner that we've been showing and sending in the emails as well as showing in our little breaks between sessions. So you can see how each open measurement group shows up in that little banner. It's very clever. So going back to our dev environment, you just be able to see, we used to have in our production environment, we have this timeline hidden behind the map, and you'd have to click a button to switch over to it. But now we have that further exposed down below the scroll. And we've been doing the redesign of our outage pages, and we'll be switching to the country, region, and network level view. But we're very excited about all of that work. Finally, this is something that we're still working on, but made a lot of progress and should be released later this summer, is upstream delay. So this is where we're looking at trace route data and providing both delay and path information. This is just available at the ASN or ISP level. So if you're, in this example here, you'd be looking at, actually, this is MTN Rwanda. And so if you were on that page in IODA, below you would have a visualization that shows the trace routes. So what's the last hop networks or the penultimate networks connecting to AS 36890 or MTN Rwanda, as well as a measure of latency. And what you're seeing here is we found an example of an outage on MTN Rwanda. This is the view of it in our connectivity signals. And if we looked at our upstream delay signals, we could see that traffic did switch to this other network. And so you can see a change in the route and in the routing path. And then here below, you can see that this had an effect on latency or round trip time, and that all of these other networks pretty much dropped off as it moved to a different trace route path. One more example we wanted to show, and this is from Venezuela. It's from last September, so this is September 2024. This is, of course, in the wake of a very contested election where a lot of protests were happening. And we've overlaid our blue active probing signal with the path data. So you're seeing the number of connections the last hop or the penultimate network is making to a final destination AS. And we were looking at this, of course, because when we know something's happening politically, socially, we will monitor our networks. And we actually heard from Andres, who said, this drop in active probing, we experienced an actual loss of connectivity. Users in Venezuela reported experiencing this. But this one in active probing, we're really not sure about. And we'd like to understand more why IODA saw this drop in active probing. So to investigate this more, we overlaid it with the trace route data, and we could see that there was a shift in the path to this network. And so that could help explain why they didn't experience any change in connectivity. And so we're excited that this new data set will provide just more context, more information about what's happening upstream of this network to see how data might be shifting, or trace routes might be shifting, paths might be shifting. This is what it'll look like in the dashboard, more or less. Still a work in progress, but you'll be able to see the latency and round trip time for the combined kind of penultimate networks as well as individual. And then you'll see that trace route number of connections from the penultimate network. So future plans, as I mentioned, we have a lot of releases coming out this summer, as well as the dashboard redesign. Zach's also been leading a team working on integration of Mozilla telemetry data. And then, as I mentioned, we have these new animated videos that have also been a long time that we've been working on that explain IODA signals. And we got that feedback after we shared our one of our new user guides that, it definitely helps people understand how to identify an outage, but they still wanted to understand more about the signals and how we measure connectivity. So these videos are meant to provide that. And then in terms of projects that we're working on, Zach's leading a group of students that are compiling global power outage data set, as well as open source code for scraping that. And we're developing a contribution system to support localization of IOTA. Folks may know that you can change the language to Farsi, and we had our partners support that, but we know we need to do a lot more with localization and not just rely on in-browser translations. So we're excited about that. And then we're also working on trying to automate a piece of our outage documentation work. So some of you may be aware of a data set where we document outages that we see in IOTA. And this is a very human in the loop process where daily a human is looking at outages in the dashboard and documenting them, trying to verify them and figure out the cause. But we document the start time, the end time, what network, what country, what region is associated with it. And we are working with a group of students who are trying to automate a piece of this to help that be more efficient and more productive. So that's it for, I actually probably missed a few things. There's a lot going on, but that's a look at some of our future plans. And I guess I finished very early. If anyone has questions or feedback on how IOTA could better serve your use case, we'd be really, really happy to hear about that.
Thanks, Amanda, for the great presentation. Yeah, if anyone has questions, please post them either in the Q&A or the chat. None have been submitted so far.
Great. And Zach is online if Zach wanted to kind of further elaborate on anything that I went through, please feel free.
I guess just off the top of my head, some of the other stuff we've been working on is we have some longer term work that probably will be at least a year before it shows up in IOTA, but we are trying to improve IOTA's telescope signal kind of through multiple fronts. One is we've actually run into some issues where some network scanning campaigns are causing some odd and noisy behavior in IOTA. We've been working to filter those out. We're also working on improving kind of the comprehensiveness, like adding additional networks. And basically at Georgia Tech, we're working on running a telescope in the spare time where it's using unassigned IP addresses, basically. So this is all more research, and it's still kind of academic research, and we're trying to switch that into applied research and eventually incorporate it into IOTA. Trying to think. There's also been a lot of upgrades to our infrastructure on the back end, and we're trying to make things more resilient and robust. But of course, there's always new things that pop up, and kind of similar to what Maria was saying with the funding situation, just kind of keeping the lights on for this academic soft money funded project has always been a difficult task, but we're working very hard to both improve and keep the lights on. Let's see. Yeah, there's a comment from Pavlos. Do you have any annotated, labeled by humans or algorithms data set of outages, that is, which people can look at for data analysis with Python, not only through the UI? Amanda, I'll let you answer that one because that relates to some of your work.
Sure, yes, Pablo. So the automation project I was talking about is trying to work on a historic data set that we have. So from 2019 on until, well, currently until last October, and we're working to fill that gap. We do have a data set of daily documented outages that we see in IODA. This was the data set that Zach was first author on a paper where we joined that our IODA outages with the Keep It On data set to compare spontaneous outages to shutdowns. So there's actually a whole repo and get page on with that data set and with our methodology. I think that data set goes until that we use for the paper is until 2022. But yes, we do have that data set, and we're working on ways to just, with our limited capacity, be sure that we can keep it up to date because we know that that is a useful data set. But we'll be happy to share what we have currently. And I also wanted to mention, I forgot that Zach, you wanted to mention vantage points for the traceroute data. Did you want to speak to that?
Yeah, I had one follow-up, but I'll answer that first. With the upstream delay project, we kind of have a kind of software. It's a Docker container that we've been setting up on a Raspberry Pi. It has fairly kind of intense bandwidth requirements, but this is basically part of our scanning data, running a lot of trace routes very efficiently in a stateless manner, but it still requires kind of a consistent chunk of bandwidth. But if anyone is interested in hosting, feel free to reach out to us. The other thing I wanted to say is Amanda referenced the Destination Unreachable paper, and I kind of wanted to circle back to a comment that Maria made earlier about censorship and political mobilization. That's one thing, feel free to point to. It was part of that paper was a study with some political scientists where we did find very strong evidence, basically, that compared to the spontaneous outages that Amanda referred to, these government-ordered events are much, much more likely to occur on various types of political mobilization, including protests, elections, and coups, for example. Let's see. There's a couple questions that popped up. There's one from Mesvin. Is it possible to get access to the raw data sets on internet outages other than the dashboard? So Amanda kind of already answered this. Was similar to Pavlos's answer. I'll share a link to here right now to the API in the chat. But that data set is kind of like our investigated and curated one. Besides that, if you're trying to get programmatic access to something like what's available in the dashboard, you can use the API under the outages header. Basically, the alerts and events will give you that same data that you can get from the dashboard, but you can get it programmatically if you wanted to write a script or something. And then two, how to identify internet outages that happen due to power outage that are caused due to government shutdown. So right now, this like the power outage project is still very much in the early stages. It really depends on what data we have access to. But our goal is basically to scrape from different public websites that often are run by government organizations, where there's reporting requirements for power companies to disclose either planned maintenance or power outages that occur spontaneously that affect a certain number of people or households or some duration. So we're currently working on collecting this, but it's a very long task because each country and sometimes each power provider has to be handled independently. We are planning to kind of announce this project eventually on IODA and welcome open. It's an open source project, but we will welcome contributions for others. Right now, we're actually working though on kind of streamlining this and making it more easy to contribute and operationalize, as well as making this data sets or the data set that we collect from this publicly available. And the plan is to eventually incorporate this data that's kind of been post-processed into a standard format into IODA's views and APIs, where basically, for example, if you go to a dashboard page on IODA and there's some a view for a country and there's some disruption in the signal, but we also see that there's been reports of a power outage, we might add an annotation to the page that says, note, there's reports of a power outage from this time to this time, and possibly even annotating on the graph in some way. So that's, like I said, still early stages. There's a lot of barriers to accessing this data. In some cases, certain countries seem to restrict access from outside the country. So it'll be a bit more complicated to get access to that data. But I think this is a promising thing, and it'll be particularly useful in scenarios where people are trying to differentiate between the government ordered events and one that's a result of a power outage. Let's see. Next, how does IOTA handle false positives like BGP misconfigurations? I guess I'm a little curious if there's any more details here. Depending on the BGP configuration or misconfiguration, for example, if it's something that does negatively impact reachability, that might show up, for example, in the active probing signal. So if it's still announced, but there's some, like a prefix is still announced, but there's some actual reachability issue, then that might just affect the how do I say this? The traffic. But this is something that it should also show up, for example, in the upstream delay, as we see the shift in how that traffic is flowing through the internet. But yeah, I'm not sure if the misconfiguration includes cases where, a prefix, for example, is withdrawn and no longer announced via BGP. That would already show up in IOTA, for example.
And I'll just
Yeah, go ahead.
Zach. So when you say false positives in IOTA, I automatically think about our alert system. So this kind of speaks to the next question. So IOTA has an alert system where it detects abnormal drops in our signals, and you can see how we run that detection method. But we do have false positives as well as false negatives, where there is an outage event that we don't generate an alert for. But with false positives, or where we do see a drop in connectivity, like I said, we would check radar, we would check with Kintech, we would also reach out to our Keep It On folks, or if we have partners in the area or collaborators in the area, we would reach out to see if they experienced anything or see anything in their data that validates an abnormal drop in our signals. We do have a real-time alert system. When you go to our dashboard and you see the map, the country level map and the tables, that all of those visualizations are based on our alert system, where we're showing you an outage score based on the significance of the drop, or like the value of the drop and the time period of the drop. And we also aggregated across signals. And so you'll see the highest score for places or networks where more than one signal is experiencing an outage and triggering an alert. So we do have that, and we do have the API, the outage API. So there's alerts, which are really when a signal starts a start time of an abnormal drop, as well as the end time of when the alert system thinks it recovers. So those are alerts. The event is the duration, and then the summary is basically an aggregation of the event, the outage event. So you can see that you can query all of that in our API, but you can also see it in various views on the dashboard. Anything you wanted to add, Zach?
No, I don't think so. I think you answered it perfectly. I think we can move on to just marking some of these as answered. There were some additional questions from Mesfin. Overall, today's webinar focused on measuring interference on internet. Is there any plan to push how to measure the impacts of such interference on economy, political, social integrations and interactions, etc.? I guess we can kind of open this up to everybody if they want to chime in.
Yeah, I know that folks from ISOC were here, and I know that they have done some work to attempt to measure that impact as well as various other researchers. We have definitely thought about, for us, I think we would want to do that through a partnership with economists, with interdisciplinary experts from those fields. And you're correct that we have been more focused on our own measurements. That's our perspective. I don't know if other folks want to add to that.
I could just chime in for MLab that right what we heard from Pablo today is we've been focusing a lot on our infrastructure and then also trying to create ways and frameworks for experts like journalists and advocates to better understand the data. So that's part of why we are working on the Internet Quality Barometer. So I think the answer is yes, but we're trying to work towards it to make it more accessible and but not try to do everything on our own where there's expertise elsewhere already.
Yeah, can you hear me? Can you hear me? Yeah, perfect. On Uni's behalf, we do not do any systematic research of the impacts, but as part of some of our reports, we do our best to include some qualitative analysis of how the impacts affected specific communities on the ground. Yeah.
And just to add to that, I just read in the chat a link to the interview findings from our research report documenting media censorship in Russia, for example, or the one in Senegal.
I guess real quick, I just wanted to add in our destination unreachable paper that Amanda mentioned earlier, just to circle back to that. It actually, part of that goes a little bit the other way, and it looks at some of the political and economic and social indicators and seeing how useful that is for predicting the occurrence of internet shutdowns. But I know there's a lot of interest in the academic field, and I know there's been multiple efforts on this kind of in terms of calculating what the cost of these internet shutdowns is on people. And I think that's actually, as economies develop, becoming one of the ways that that pushes back against the government, just in terms of or disincentivizing the government from using such a heavy-handed tool by the fact that there is this significant economic impact from the internet shutdown. But just wanted to ask, yeah, if other people wanted to chime in further, perhaps Sensor Planet, or we can move on to the next one.
I mean, I can bring up the our like Google Trends based learning tool that we are working on gets into this in terms of it's not directly measuring network based behavior. It is measuring like user and social reaction to ongoing events.
I guess next, I think they'll keep this open with the AI tools and agents, how it can impact internet measurements. One kind of related question, anyway, that I see, or sorry, related research that we've been doing is we have been trying to collect information about like the different networks on the internet, for example. So we've been, from a research perspective, really interested in kind of classifying what's either the business sector or like the target kind of user for a network. If something is like a business AS or whether it's more kind of residential consumer facing, or I'm saying AS, but for autonomous system, but also ISP is the other term. But I think that this kind of classification and getting kind of like local intel by using information, especially on like the websites that these ISPs are running, it allows us to kind of get a little bit more context or insights into what exactly the impact on these disruptions is for users. And so I would say right now that's kind of the main way that we've been incorporating, LLMs in particular into our research. But again, I wanted to let, or Amanda, you wanted to chime in?
Yeah, I just wanted to add another use case of how what Zach's talking about, this classification of ISPs, is helpful. We had a journalist reach out and ask if we could confirm something they had heard, which is that the government buildings in Iran and Tehran were still connected to the internet. So what Zach's talking about is maybe if you could see a specific government network, because we do see, Georgia Tech has its own network. Universities have their own networks. At the network level, you could see potentially, okay, these are a specific sector, specific organization that still has access to the internet while others do not. But this is a great question, and I just wanted to say thank you, Mesfin, for staying up late with us, and I'll pass it to Pavlos.
Yeah, I have a couple of ideas that could add in this discussion about AI tools that could help us. Given that a lot of the users of our data and our findings may not be network internet measurement experts, they can see the data but maybe not understand. A potential good direction for making value out of this data for these people could be to build AI agents that talk to the data. So, like ChatGPT can find some documents and you can chat with these documents. The same thing can be built with the data. So, someone can ask for these date range, what's going on. And okay, it requires some work to get to that point, but yeah, I would like to mention it as an idea. We have some background on that, and if there are people interested in that and working with this type of technologies, feel free to reach out to us.
Happy to move on to other questions, but I guess I just wanted to check if there's any other groups that wanted to chime in about AI tools or agents. Okay. Yeah, moving on. I think the next couple questions are, I'm just gonna mark them all as being answered because I see them all as kind of related. First was, are there any geographic or network blind spots where IODA's data is less reliable? And then can you comment on the source of GeoIP? Do you have a sense of where the geographic distinction is not as good? I would say generally at the country level, the IP geolocation works pretty well, and this is based off of academic research over the past decade. We do IP Info grants us access to their data sets, which we use in the backend for IODA for mapping blocks of IP addresses, but according to the specific IPs within the block to different regions. I would say, yeah, there are definitely some regions where I think the IP geolocation at the subnational region level is potentially an issue. At least the cases that I've heard about, for example, is in Iran, where often some of the providers there, like cell networks or kind of consumer residential access providers, will reassign daily IP addresses throughout the whole country, basically. I don't have personal experience with this, but this is kind of what I've heard. I think there are definitely cases like that where, especially with IPv4 and IP shortages, that they need to consistently like reassign from the same block across a large area. So I think learning those blind spots, knowing how we can do better, is something we need to work on. At the same time, though, we are, over the last year, one of the invisible updates we did is we switched to using IP info, updating it every day. and be more consistent. Where sometimes we would get, our IP addresses mappings might get a little bit out of date, and we're updated more manually. There's been a lot of updates in the back end. I also wanted to speak to the first question a little bit, where network blind spots, where IODA's data is less reliable. So I think there is. We had a paper last year at PAM, the Passive and Active Measurement Conference, where we were looking at, for example, in the active probing signal, how using different protocols, potentially using TCP, UDP instead of what we're using right now, which is ICMP, how that could potentially impact what we see. And it definitely does seem to be that we noticed a trend where in the global south, for example, networks were less likely to be responding to ICMP probes, it seemed like. Whereas if we compared those with data from census.io, which they do ZMAP scans of the whole internet, it did seem like, and the ZMAP scans use TCP or UDP on different ports. It did seem like those were able to get more responses more consistently. And so this is one thing that we've been looking into. It's on our long to-do list, and it's just a matter of trying to prioritize the things that we think are the biggest impact. But I do think this could be a promising thing for the future, and we are looking for funding support to work on this. But yeah, I hope that answers all the geo questions. Let me mark those. What's the typical time lag between an outage occurring and IOTA showing it? Amanda, did you want to this one?
No, I was just marking that it's being answered live. Go ahead. I mean, but you can go ahead.
Yeah, go ahead. Go ahead.
Okay, so it depends on the signal. Our signals vary by the frequency that we collect it. So I believe, here, let's just jump over to our, our resource page, live demo in the glossary. So BGP is every 5 minutes, active probing every 10 minutes, and telescope. Zach, are you aware of the frequency?
Yeah, it's every minute we count the number of source IP addresses. Yeah, IPs per minute.
Great. And then GTR, Google Product Signals, does have a bit more of a delay, where it's every, there's a lag of more like 60 to 90 minutes. So it depends on the signal of when we start seeing a drop, but and it also depends on the nature of the outage in terms of how we start seeing it manifest in the dashboard. But I think this is a good starting point of knowing just the frequency of how often we collect these measurements. Anything you want to add?
Yeah. Yeah, I was just going to add, so, with the BGP signal, there can be a little bit of maybe, depending on the source, a little bit of a delay from when the data is available to when it's incorporated. The other sources like active probing and the network telescope are generally quite quick. We would call them near real time, like all of them actually. But we have noticed, for example, with the Google Transparency Report, I think there have been some cases where there's a little bit of lag for some reason. And I don't know if this is something on Google's end and, maybe a script that's supposed to process some data and publish it via the API if that, didn't run for some reason. So I think that can be kind of noisy, but in general, the kind of lag is associated with the granularity at which the data is published. I think I'll move on to the outage prediction system. Is it feasible? Question. For this one, I was just going to say, I guess we're really apprehensive, or at least I am anyway, about saying an outage prediction or something that can, predict that these events are going to happen. I guess I would say our thinking is more like using them for kind of regions or countries of interest. is how I would phrase it. And it's just something that is a case where we'd want to keep an eye on it. And I think for this, it would actually require a lot more context. And actually, maybe Amanda, yeah, you could speak to this a bit with some of the other work we've been doing. But I think some of the data sets, for example, about like upcoming elections, from the Destination Unreachable paper, we also mentioned the social, political, and economic indicators where maybe some combination of these could highlight potential regions or countries that maybe deserve extra focus in the coming weeks or months or days. But yeah, Amanda, I wasn't sure if you wanted to talk about some of the work you've been doing with Aggie or.
Yeah, I mean, just to add, the Destination Unreachable paper is a really good start for us trying to learn how we can help our users distinguish between a spontaneous outage and a shutdown. And we really do want to integrate more of that into the dashboard. And yeah, I am working on a project where we're using an open source tool called Aggie to aggregate IODA alerts, Cloudflare anomalies, potentially IODA Ludi alerts into one view where those alerts can be investigated as one incident or a set of incidents. And that tool has actually more been used to aggregate social media. It can aggregate any kind of internet content. APIs are more difficult with social media these days, but the idea is that you have one tool where you're looking at alerts across systems and tracking incidents in that tool. But I also wanted to see if Censored Planet wanted to talk about SynAlert. I think I said it right, SynAlert.
Yeah, I mean, we don't see this as a predictive system in a lot of cases, either. Um, in a lot of cases, we see that users only begin to react to events as soon as platforms start becoming inaccessible. That said, there are cases where we see reactions in advance, where if a protest is happening that is planned, people might start sort of downloading tools in preparation for that. There are also cases where people might anticipate censorship that may or may not ever occur, such as around like elections or protests and such. Um, but yeah, we're also hesitant to say anything about like the possibility of this being predictive.
Makes sense. All right. Is it possible to be added to a mailing list, future communications? As of now, Mesfin, the Open Measurement Gathering does not have a mailing list, but I would encourage you to join the Keep It On list or the OTF Talk list. Do folks have links to how to join that? I have the Keep It On email that I'm going to post in case that is helpful. And then for talk, OTF Talk. These two listservs are a great way to get updates from the Internet Freedom community on events or ongoing work.
Yeah, I was
Yes, you
going
would
to
have to
say,
request. But I think
yeah,
you could email those email addresses is my guess. Okay, thanks. Okay, so there's a lot of helpful information in the chat about how to join those listservs. Okay, there's a last question. Can users define custom alerts for specific ASNs, countries, or regions? Yes, we've just been working on this with the aggregator project that I mentioned, Aggie, where we're focused on a specific country, and we are able to query just for specific alerts related to the regions, the country, and the ASNs in that country. And I know with Radar, Cloudflare Radar, you can do the same. If you need help with that, please reach out. I'm going to add IODA's email address to the chat as well. Okay, great. Thank you for that OTF note from Zeneb. Okay. I think we've answered all of the questions in the Q&A and in the chat. Thank you everyone for being so active in the chat and providing resources and for staying for the last open measurement gathering session. Very happy to have spent this time virtually with you all. And yeah, thank you very much.